Welcome back to London Gold, everyone. Thank you so much for the support. So you've balanced your chemical equation, and then the next thing you have to do is insert state symbols on the reactants and products side. So how do we do this? We have solids, liquids, gases, and AQ, aqueous. So today I'm going to walk you through a simple step-by-step process that you can apply to get the correct answer every single time. And also in the description below, I've attached a table that you can use for future reference. So with that said, let's take a look. Step 1. When you have equations that look like this, start with the obvious molecules that you already probably know, such as water, such as carbon dioxide, such as oxygen, things you would have learned before you've come to balancing equations, chemical formulae, and state symbols. So what do I mean by obvious molecules? Well, this, where carbon dioxide is a gas, hydrogen is a gas, oxygen is a gas, water is a liquid, and so on. So you finish with this. Most of the elements in the periodic table are solids. So once you've identified any gases, then the others are likely to be solids. So for example, carbon. The only liquid element in the periodic table is mercury. Then we have methane on the right hand side, which is always a gas. And then the top two, calcium carbonate and calcium oxide, well, they are ionic salts. And generally, when you have a metal in a compound, it tends to be solid, which leads us nicely on to rule number 2, which is... So firstly, let's consider what a salt is. A salt in its most basic form is a positive ion bonded to a negative ion, usually by ionic bonding. And the vast majority of the time, the positive ion will be a metal. So, for example, sodium chloride, potassium sulfate, calcium nitrate, and a non-metal positive ion would be ammonium, such as ammonium chloride. Salts are formed through ionic bonding, the electrostatic attraction between oppositely charged ions, and they have varying solubilities. So, are there any general rules you can follow to work out what their state symbol would be? Yes. So, loosely, rule number 1, all group 1 salts are soluble. For example, nitrates, carbonates, sulfates, phosphates, hydroxides. So that means when you see a group 1 salt in a chemical equation, it is going to be usually AQ. Rule number 2. All lead compounds are insoluble apart from nitrates. And rule number 3, most carbonates are insoluble apart from group 1 and ammonium carbonates. Rule number 4, hydroxides are insoluble apart from group 1 hydroxide. Let's take a look at what these rules would look like in a table format, where I've also included some extra rules for you to learn. And this table is available for download in the description below. Remember, if the salt is insoluble, it will have the solid state symbol. If the salt is soluble, it'll have the AQ, which means aqueous state symbol. Rule number 5. Acids such as HCl, nitric acid, sulfuric acid are always aqueous when reacting with other species in solution. So with alkalis, insoluble bases, and so on. Generally, your acids are going to be AQ. So let's see what these rules look like in practice. The first one, start with the obvious, which is usually the elements. So hydrogen is a gas, calcium is a solid. Then acids reacting generally tend to be aqueous. And then calcium chloride is a salt formed in solution, so that is aqueous as well. For B, start with the things that we recognize. So we know that nitrates are always soluble. Group 1 salts are soluble, and then silver chloride is a solid precipitate. Example C, again, start with what we know, which is nitrates are soluble. Group 1 salts are always soluble. Finally, lead compounds are insoluble apart from nitrates. So lead chloride will be solid. Now for some further examples. Starting with the first, and just like with the previous 3 examples, we look at the elements and assign those state symbols first. So zinc is a metal, so therefore a solid, and hydrogen is always a gas. Then we have the acids, always AQ when they're reacting in solution, and the salt form zinc sulfate is also AQ. For the next one, ammonia can actually be a liquid or a gas. So usually you will be given more information about this in the question. So in this particular case, I've taken it from a question where ammonia is a gas. It is reacting with hydrogen chloride gas as opposed to hydrochloric acid. Again, I was told this in the question, so it's a gas. And it formed a solid salt, so it's S. This extra information was provided in the question itself. This could easily have been ammonia as a solution, AQ, or as a pure liquid, plus hydrochloric acid, AQ, to produce ammonium chloride as a salt dissolved in water. So for E, it's an interesting one because it can be either gas state symbols for hydrochloric acid or hydrogen chloride and ammonia, or aqueous depending on the situation. Finally, for F, we start with the element first, iodine, solid at room temperature. Then we move to things we recognize, so group 1 salts. As you can see, they're always AQ, which leaves us with only one thing left to assign, which is water, obviously being a liquid. And that's it. If you have any questions, comment down below and I will get back to you. And if you've had any value from this, please like and subscribe, as it helps grow the channel and gives me the time to produce these videos for you. Otherwise, thank you for watching and I will see you in the next one.